How's it going, everyone? Today we're going to dive into a project that blends practicality with a bit of creativity. We're going to be optimizing GPU cooling using a 3D printed mod. What's the inspiration for this? I recently stumbled upon the clever design of the NZXT H5 Flow case. It has a built-in directional fan mount to channel air straight to the GPU. It's a proven method for reducing temperatures, and I wanted to see if I could adapt this feature for my Corsair 5000D airflow case and make it accessible to anyone with a 3D printer. So here's the issue. Most PC cases, even those optimized for airflow, aren't really designed to direct air efficiently to specific components like the GPU. Front intake fans do a decent job of pulling in cool air, but much of it disperses before it reaches your graphics card. And in a high performance rig, every single degree of cooling matters. So I set out to create a simple yet effective solution, a 3D printed airflow guide. Now let's talk about the design process. I started with a basic concept, a curved airflow guide that sits in front of the intake fans and channels air directly to the GPU. But as is often the case with prototyping, the first iteration wasn't really perfect. Well, the initial guide wasn't quite long or even tall enough. It didn't direct the airflow efficiently, and there were small gaps where air could still escape. So I had to go back to the drawing board. This is where the beauty of 3D printing really shines. I fine-tuned the dimensions, extending the guide to cover more surface area and ensuring a snug fit against the case. The second iteration was much better, precise, secure, and designed to channel airflow directly to the GPU. Let's see how it works in practice. The final print took about 6 hours and was made using standard PLA filament. PLA is easy to work with, but if you're concerned about heat inside your case, you could always use PETG or ABS for better thermal resistance. Now comes the exciting part, the results. To keep this as controlled as possible, I tested both idle and load temperatures, making sure the room temperature stayed constant. And the results were pretty impressive. At idle without the 3D printed mod, the GPU temperatures range from a low of 35 degrees to a high of 36 degrees, averaging about 35 degrees. With the airflow guide in place, idle temperatures dropped to between 30 degrees and 33 degrees, with an average of 32 degrees. That's a whole 3-degree drop in average temperatures, which is significant for idled conditions. During a Furmark stress test, the differences were even more pronounced. Without the mod, the GPU hit lows of 35 degrees and highs of 62 degrees, averaging around 59 degrees. But with the 3D printed guide, temperatures dropped to lows of 30 degrees and highs of 61 degrees, with an average of 56 degrees. That is also a 3-degree decrease in average temperatures under load. A very meaningful improvement for heavy usage. These numbers show just how impactful a simple mod can be. It is always so satisfying to see a project come to life and deliver real results. The differences might seem minor on paper, but in terms of system stability and performance, those few degrees make a noticeable impact. So you must be wondering then, why does this thing work? It's all about airflow dynamics and minimizing turbulence. Picture the airflow in your case like a stream of water. Without direction, it just splashes around and loses all of its energy. But when you guide it smoothly, it flows much more efficiently. By placing this airflow guide, we're essentially creating a laminar flow that targets the hottest components in your case, and in this case, it's the GPU. Now you might be wondering, is PLA safe to use in a PC case? For most setups, it's fine. PLA starts to deform at around 60 Celsius, and even high performance PCs don't usually get that hot inside the case. But if you're overclocking or running an especially hot system, consider using a more heat resistant filament like PETG or ABS. Now this whole project got me thinking, what other components could benefit from better airflow management? Maybe your CPU cooler, or even your PSU area. In the end, This 3D printed airflow guide is a testament to the power of small, thoughtful improvements. It's accessible, customizable, and effective. And while I tailored mine for the Corsair 5000D, the concept is versatile enough to be adapted to nearly any case. If you have a 3D printer, why not give it a try and see how it transforms your setup? Thanks for sticking around. If you enjoyed this exploration into cooling optimization, consider subscribing for more projects like this. And remember, the best ideas come from the community, so let's keep the conversation going in the comments.